Alright, you guys, let's go ahead and get started here with lesson 6.2. This is shifting functions. In this case, guys, we are going to be seeing graphs and equations in this case where we're going to be doing transformations, or we're going to be seeing how the transformation happens. Just a few things, guys. Horizontal shift in this case talks about directions from left to right. Vertical shift up and down. A squeeze or a stretch in this case talks about a scale factor, and most of the time it's actually a number being multiplied. And just in this case, guys, something quick. We do have parent functions. We are going to be working with most of these functions here. But in this case, guys, a parent function for a line is y equals x. It should follow this format. Once we see transformation, it actually changes direction, moves up and down, and so on. Next one is the quadratics. In this case, parabola. We have y equals x squared. Then we have the absolute value one, which is y equals absolute value of x. It is a V shape. Y equals x cubed is more of an S shape. Y equals square root of x, in this case, would be in this format where it starts at the origin 0, 0, and then it grows from there. So let's go ahead and start off here with example 1, guys. Make sure you guys sketch this out. And in this case, we want to go ahead and write a formula for the function g in terms of the function f. So once again, we want to write a formula, the transformation that happens from f to g. So in this case, we want to go ahead and see how we go from the absolute value of f of x to the absolute value of g of x. And in this case, we are focused on the vertex. So for f, it has the 0.32, and for g of x, in this case, it's -2, -5. So in this case, guys, we are going to be using a formula in this case, and the formula, how it works is that horizontal shift is always going to be, in this case, the number or the term that is going to be subtracted with the x or a variable. And then we have a vertical shift that is going to be found on the outside. So in this case, I have g of x equals f times x minus a horizontal shift plus our vertical shift. So in this case, guys, we want to go ahead and see how much we're moving in this case from this point to this point here. So question for you guys is, how many spaces do I move in this case to the left? And that is 1, 2, 3, 4, 5. And that is going to be a -5. And in this case, how many spaces we move down? I have 1, 2, 3, 4, 5, 6, and 7. And since we are moving down, that is a -7. Now, in this case, guys, because we moved 5 to the left, it is a negative, and that actually represents our horizontal shift. So I'm going to go ahead and do g of x equals f times x minus our horizontal shift, which was a -7. I did double parentheses there. Or actually, we don't need double parentheses. Just do -7. All right. And then our vertical shift in this case is how much we moved up and down. In this case, we did move down, so plus a -7. Now, let's go ahead and simplify this out, guys. G of x equals f of x. Double negatives in this case, guys, tell us to multiply, so negative times a negative is a positive. And I think this was supposed to be a 5. 5, and this makes this one a 5. There you go. And then positive times a negative is negative. So this here is the formula for g of x. So we do a transformation from f to go to g, 5 units to the left, 7 down. Now, notice in this case, guys, we did count that we were moving 5 spaces to the left. But why do we have a positive here? In this case, guys, the formula does call for a negative. It does start off with a negative. So if you're moving left in this case, your horizontal shift will be reflected as a positive, but doesn't mean it's going to be moving to the right. It's actually the opposite. So our horizontal shift, guys, all the time is actually going to be representing the opposite. It's going to be the opposite in this case. Same way, if I would have moved right, this would have been a negative times a positive, which would have made this a negative. Once again, doesn't mean it's moving to the left, it's actually moving to the right. So it's opposite, all right? And we can see it here. From the graph to the formula, that was negative, but now it's presented here as positive because those are the opposites there. Now, let's go ahead and move on to this next one. Once again, we want to go ahead and do the same thing, but now we're focused on building an equation. Now, it is telling us to find the equation of g of x and use that as an equation to find f of x. And in this case, guys, we're actually just going to be finding the equations for both of these. And all you need for these equations, guys, is your starting point. On the other ones, we do have a vertex. This would be considered a starting point here. So, start off with g of x in this case, guys. We are given the point -7 and 4. And in this case, guys, horizontal shift, like we said, is left to right. If we're looking at a table in this case, or a graph actually, x is the one that moves left to right. So horizontal shift is represented by our x value. Vertical shift is represented by y. So let's go ahead and start off with g of x here. And I have g of x equals, I did start off with the absolute value, guys, because this equation, if we go back to the parent function, it would be this one, and it does have absolute value. So that's why we did absolute value there. Is the no, not absolute value, I'm sorry, the square root. Square root, my mistake, guys. This is a square root, not absolute value. My mistake there. So in this case, guys, we do have the square root x minus, and in this case, horizontal shift is represented by the x. So that's a -7. And on the outside, I have plus my vertical shift, which is 4. So let's go ahead and simplify this out. And I have g of x equals square root of x. Double negatives becomes a positive. So x plus 7 plus 4. And this here is the equation of g of x. So that means if I were to graph this on decimals, I should be getting that same equation over here as g of x. Now let's go ahead and follow the same format here for f of x. And in this case, guys, we're still using the same format as x minus. And in this case, our horizontal shift for f of x is going to be a -4 plus a -2. So once again, let's go ahead and simplify this out. And that becomes the square root of x. Double negatives again, negative times a negative is a positive, so that becomes +4. And then positive times negative is -2. So that there is the formula for f of x. So we have our two formulas there. All right.